Our last example has us trying to write the equation of a hyperbola, having been given some information about its features. So we are told that the vertices are at -2 plus or minus 5, and our foci are at -2 plus or minus 8. So from that information, we want to piece together the equation of our hyperbola. So the first thing I'm going to do is plot this information to see if I can start to get a sense as to which way this hyperbola is oriented, and then we can start to find the values of a, b, and c, the location of the center, to try to piece together the equation. So I'm at -2 plus or minus 5, so -2 here, plus or minus 5, roughly there and there, are our vertices. And then if we go up 8, so to here, roughly in here, we have our foci. So here's 5, here's 8, -5, and -8. So first thing that is obvious is we're working with a vertical axis. So everything is lined up in the same vertical line. And so if we go back to our templates up above, we can hopefully see that that means that we're looking at a hyperbola where the y squared is coming first. We've got y minus k squared over a squared minus x minus h squared over b squared equals 1. So that's the equation where we have to fill in all of our information. And so we've got to figure out what h and k are, the coordinates of the center, and then we've got to figure out what the values of a and b are so that we can plug those in. So first of all, the center is going to be halfway between the vertices. It's going to be halfway between the foci. So hopefully that's obvious that that's going to be right here at the point -2, 0. So that means as I start to fill in the information here, I've got y minus 0, or we can just leave it as y squared, and then x minus h squared, so x minus -2 becomes x plus 2 squared. So we've plugged in the value of the coordinates of the values of the coordinates of the center. So now we need to figure out what our values of a and b are. So recall that a is the distance from the center to the vertices. So right here, from center to vertex, that distance is 5. So that's our a. So that means a equals 5. So I can go ahead and plug that in here. So I've got y squared over 25. And then in the denominator of the second fraction, we need to know what b is. Now recall that the distance from the focus to the center is not b, that is c. So we know that c equals 8. So that will help us in that, make sure that equals 1 there. That'll help us in that we know that a squared plus b squared equals c squared. So if we know a is 5, so a squared is 25, and we know c is 8, so c squared is 64, we can now solve for b squared. So if we subtract 25 from both sides, we're going to get b squared is equal to 64 minus 25 is 39. And as we saw with the ellipse examples previously, we don't actually have to solve for b, we just need to know what b squared is, since that's what we need in the equation. So I can just plug in 39 right there into my equation. So that's how we can, from the given information, piece together the equation of a hyperbola.